Hey boys and girls, we are going to go over lesson 10-4, critique reasoning. So you will need your workbook, a pencil, a multiplication chart just in case, scratch paper, pencil, because you are writing down as I am teaching. Here's our learning goal up here. I can critique the reasoning of others. Go ahead and open up your books to lesson 10-4. We're on page 441, so make sure you have that out and open. And we are going to read through our solve and share. I'm going to give you time to respond to each of the 4 responses we have here. Remember, today is all about critiquing reasoning. So your first step is going to be, number 1, check their work. So it's just like you're kind of pretending like you're the teacher. You're trying to see, okay, did this kid do it right? Did they do it incorrectly? Don't just guess. Look at what they said. You try it, and then you can really justify if they're right or wrong. Here is our prompt. A cross-country coach recorded the team's practice runs and made this line plot. The coach had each runner analyze the line plot and write an observation. Read the statements and explain whether you think the runner's reasoning makes sense. So first we have Olivia. The distance we ran the most often was 3 miles. Go ahead and enter. What do you think about what Olivia said checking out this line plot here? Okay, then we have, actually let's just go ahead and go over Olivia and I'll pause each time. So the distance we ran the most often, remember that's our mode, was 3 miles. And so if you come here and you look at your 3 miles, we've got 1, 2, 3, 4, 5, and there's not 5 on any other of the distances that they're running in miles. So is she correct? Yes. That's the mode, right? All right, here's Natalie's. The team ran 8 different times, each time for a different distance. So think about that. Are there only 8 different times up there? All right, for Natalie, unfortunately, the answer is no. The team ran 8 different distances. We've got 1, 2, 3, 4, 5, 6, 7, 8. But the number of times are the X's above it. So they actually ran 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21. So they ran 21 times. And I do want you to write this down. You are critiquing their reasoning. And what I did there is I read her work, I looked back at the problem, and I checked it. And I did the work. And then my answer was different. So I know she's wrong. Oh, wait, I'm sure she's a great student, but a little off is what I meant to say. Okay, Michelle. The team ran different distances on different days. We usually ran for 2 miles or more. So Michelle has 2 here. Analyze the first sentence, and then analyze your second one. Okay, Michelle's halfway right and halfway wrong. If we are, or halfway, we kind of don't know. So the team ran different distances on different days. So because the first part's gonna be a no, and I'm gonna do B/G for shorthand, because we have multiple X's on the same one. So you'll notice we have 4 on 1.5 miles. So there's multiple days that they ran, though that same difference. So no, because there are multiple X's on distances, the miles. So I do want you to write that down. That says miles. Sorry, my curly Q arrow got me. Now the second one, we usually ran for 2 miles or more. So what you need to do here is what we've practiced a couple of times, is split your data. And you need to see, okay, how many times did they run less than 2 miles? 1, 2, 3, 4, 5, 6, 7, 8. Right? Yeah. And then how many times did they run more than that? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I think you could say more often than they usually ran for 2 or more miles. I would say yes. 13 times was 2 or more. So she's like half and half there. Okay, here's our last one, Peter. Let's see. Peter, each day the team ran the same distance or a little farther than the day before. Each day the team ran the same distance or a little farther than the day before. Okay, go ahead and see what you think about that one. Is Peter right or wrong? Okay, so for Peter, we don't know the answer to that because these aren't marked. If this said like this was the beginning of September and this was the end of September, then we could maybe justify that and say, okay, they're just running a little bit farther each day. But I would say uncertain or no on that one because the data doesn't tell us that. That's kind of a trick question there. Okay, make sure you have all of these guys down. You're taking notes because we are critiquing other students' work all day today. So you are playing teacher. Okay, for free, I guess. We're not going to pay you to play teacher. You're just going to do it. All right, let's look at our essential question. How can you critique the reasoning of others? So we've got a problem here and our line plot. I'm going to read through that and we can think about how we can critique Amanda and Drake's reasoning. Miss Kelly's class made a line plot showing how many hours of each student spent watching television the previous evening. Amanda said, no one watched TV for 3 hours. So the first thing we need to do is check her work. You will do the work with that. Drake said, no, 3 of us watched no TV. Who is correct? Explain your reasoning. So what information do Amanda and Drake use for reasoning? They base their reasoning on the data that's here in our line plot, right? And Amanda would have looked at for the 3 hours, no one watched TV for 3 hours. Okay, well, time, hours, looking at this 3, we can already kind of tell Amanda didn't pay attention, right? And then Drake said, no, 3 of us watched no TV. Okay, but did it tell us how many, if we're looking at our hours and we've got students, if this is 0 hours right here, you can already kind of start to think, who do you think is right, Drake or Amanda? Okay, let's check down below. Okay, so we can decide if the statements make sense, look for mistakes in calculations, clarify or correct flaws in reasoning. So you can't just say, no, they're wrong. You have to tell me why they're wrong and what you would do differently. Here's my thinking. So Amanda's statement is incorrect. Her reasoning has flaws. She sees the 3 X's above the 0 and thinks that means that 0 people watch 3 hours TV. Aha, she flipped it. I saw the labels, so as long as you're paying attention to your labels, that hopefully will not happen to you. The labels on the number line tell how many hours, so the X's tell how many students. So Amanda should have said there are 3 people who watch 0 hours of TV. Drake's statement is correct. So if we look back at our line plot right here, this is 0 hours. You got to just pay attention to your label. That's why every single time I say label and title, it's so important because you can get confused if it's not there. So she was thinking 0 people watched, 3 people, 3 hours of TV, 0 people. And that, I don't know why that would be it, but that's what she was thinking. And then you can tell that Drake is right because he's got, no, 3 of us watched no TV. So over here is what they were both looking at it and they both interpreted it differently. I checked it with like the 3 and you could see there was 1 X on there, but they did it a little differently down below. Okie dokie, let's try some guided practice. Renee works for a sand and gravel company. She made a line plot to show the weight of the gravel in last week's orders. She concluded that 1/3 of the orders were for more than 6 tons. What is Renee's conclusion? How did she support it? So what is she saying? She's saying that 1/3 of the orders were for more than 6 tons. She concludes that, look, 1/3 of the orders were for more than 6 tons. That's what we're going to write here. 1/3 of orders were for more than 6 tons. Also, holy moly, that's a lot of sand and gravel. I wonder what they're doing with it. Okay, describe at least one thing you could do to critique Renee's reasoning. So what have I said we have to do first every single time? Check her work. So if we check her work and make sure that the line plot over here agrees with her conclusion, then we're good to go. If we see that it disagrees, then we have to say, hey, Renee, you're wrong. You didn't do it right. So does Renee's conclusion make sense? Explain. So now we have to kind of look at this from a fraction standpoint, which I will help you with. for more than 6 tons. So she's breaking it off right here. And we've got 1, 2, 3, 4. So we have 4 out of how many orders total? 5, 6, 7, 8, 9, 10, 11, 12. So 4 12s. Can that be reduced? What could 4 12s be reduced to? It would be reduced to 1/3. So if I divide both the top and bottom by my same number when I'm reducing or simplifying a fraction, 4 divided by 4 is 1, 12 divided by 4 is 3. So 1/3 of the orders were for more than 6 tons. Is she correct? Yes. And we kind of showed our work right there. And you can kind of circle in here bloop, that we've got 4 out of the 12 total orders. There we go. Okay, we are going to keep practicing 2 more line plot problems in group, critique the reasoning, and practice a little bit with making our line plots. Tomorrow we will review and then we'll take our test.